everyone. Welcome to the Basic Science Podcast, where we freely discuss about science, research, and academia. So, obviously, the video teaser that I launched Saturday was an April Fool's, sorry, and I hope you enjoy it. And yeah, so today I'm alone, so um, we will do as what we did when I started. So today I have maybe three topics for you, and I'm gonna start with the first one, which is there's two type of people or two type of researchers and scientists, and one of them is the better version of the other. The other one shouldn't exist, in my honest opinion, but this is just me. Uh, so let's define them. And yeah, the first one is what we call hypothesis based research. And basically, how does it work is that um, when you have a hypothesis, it's based on already known facts and data that were collected prior of you asking this question or the hypothesis. And so the misconception here is that people say, oh, if you don't have ideas, you just ask a question and you do research like this. No, no, this is not hypothesis based science. And the idea is that you are observant of what is happening in the world. You have facts, you collect data, and you ask a question then. And another misconception about hypothesis based scientists is that they are biased. I mean, yes, as human beings, we would like to see our ideas become true and being real, but um, a good scientist actually will try to defy their hypothesis as humanly possible. By what I mean by that, let's say um, my hypothesis is that water boils at 100 degrees Celsius. So this is my hypothesis, and well, if I boil water and I put a thermometer in my water and see it boils at 100 degrees Celsius, um, uh, my hypothesis is true. So I'm happy. However, let's say I put salt in the water, so the salt will affect how the speed of evaporation of the water. It will increase the speed, so maybe there will be lower temperature for the water to evaporate. So my hypothesis there is wrong because I only looked at one specific context and not on different contexts or the global view of the picture. And yeah, so as a hypothesis based scientist, if you're, let's say, studying the boiling of water, you will look at different water types whatsoever. And yeah, the good science is made when you challenge your ideas. Of course, you have a hypothesis that you want it to be true, but your goal as a scientist is to define and to challenge those dogmas that you want to be true or that are already established. And this is, for example, how we got RNA vaccines, because scientists for a long time thought that RNA are impossible to work with because they're very unstable. And yeah, this is the first type of scientist. And the other one is very bad, so I won't tell you about it. No, I'm kidding. So the second type of So this is the other school of thought about science, is data or result driven science. And for me, result driven science, so the way I understand it is that you really don't have an idea about what you want to look at. So for me, already there's a problem here, because there's already facts and data out there, but you're trying to create some data, or and this is where I'm get confused to to then ask a question or a hypothesis. But then the problem here is, um, it's very cool to explore like this. Some people would say we need both result driven science and hypothesis driven science. uh, I believe that hypothesis driven science should be the main school of thought, and something we should always look at in the first place. And I think the fact that we have data driven science is a result of two things. As society, again, people, I think I already said it in many times in my first episodes, that people looking at are looking at the results. So let's say you do research, again, cancer. People want the results, which mean curing their cancer. They don't really look at what is in between. And let's say, for example, yes, a chemotherapy could cure your cancer, but also could damage a lot of healthy tissues. So for a long time, this is why we had the only option cancer people had is through chemotherapy. But now, through many dedication, years and dedication, we are able to provide those patients with more, better healthcare. So yeah, result driven science is, for me, there's something intrinsically wrong with it. So we spoke about society wanting results, but the other fact is, maybe as scientists we get really lazy, because we develop those very fancy techniques, high throughput techniques, genomics, transcriptomics, proteomics, metabolomics. So it's really easy just to say, hey, look, we can do all those very fancy and sometimes expensive experiments in the hope to get something out of it. And then we ask the hypothesis, and then we complete the story. But the problem here I see is that you're already biased, because how do you know that you've done correctly your high throughput analysis and experiments in the beginning, if you don't know what you should expect? So, and I don't know, maybe more and more as people in science fear failure. And this brings me to my second topic of discussion, is the fear of bad results. And this is really feel like a fashion in science to hide your bad results, because they don't really uh, like answer your initial questions and hypotheses. And for me, this is a bit sad, because it really slowed down science, the big science worldwide. Like, let's say you have a team in Australia and the US studying the same thing, uh, but the Australian team is studying it 5 years later, but the US team have already found that this pathway is not working for them, well, this have will obviously will never get published anywhere. So the Australian team will go through the same mistakes as the US team, and it's like a waste of time, I think, of everyone and humanity as a whole. And maybe we need something like a journal of bad results paper. So uh, every bad results that are actually for me are results should be out there, so people know which avenue to explore and which avenue to forget about. And sometimes actually bad results or results that are not answering anything, it just might be because we don't have the technology or the technique to answer it, and it might take time to get through this before. And yeah, so this bring me then to the third and last topic of today's episode, which is financing. And yes, the we as academic people, we do science thanks to the public, thanks to the taxpayer. And it's nice to in a way to improve the lifestyle and how society work, thanks to multiple people working in health science, physics, math, um, sociology, whatsoever. And uh, and I just speak as a biologist because I know this is my reality. As a taxpayer, you should know that a lot of science is really bad, because more and more people are trying to go through this result driven research. And for me, it's just a waste of time and money, because you invest a lot of money in those very fancy techniques, but if you really don't have a goal at the beginning, it is as a waste of time, if as you go through the classical hypothesis driven research, and if you find that you don't have your answer, then you can already always reformulate the question then. So this is like also a topic that is working my head. Is yes, there's the finance. Most of the finance of the academic comes from the public. There's always more and more what we see collaboration with the private, so the public can maintain their academic research, which is for me, a, it's very good, but for me it's just a very bad and sad truth, because in academia we should have this freedom of thinking. And if you go in the private sector, well, they have their set goals. We want to develop this drug to make money to help with this disease. However, in as the academic person in the sphere, you're kind of limited to this collaboration, and you cannot really explore further your science. And I'm wondering, like, if there's other ways to finance science. So of course there's philanthropy. This is a very important one. So not only taxpayers pay and give indirectly money through the government that will give back to universities, but philanthropy is a big one. And again, it's sometimes in some universities is the same is as if private comes in and put their soil in the academic sphere. Some philanthropes have their own agendas, and let's say you really want to push Alzheimer research. Well, if you put your money in there, you really are trying to help in a way this Alzheimer sphere, and in a way it's good, but you're also kind of limiting the academic liberty to explore in research in some way. It's not really to bash on any philanthropes. I think this is really amazing to be able to do again what we love, thanks to the money of all those the public, the philanthropes, the private. But I think, I don't know, like I have this sense that maybe we are slowed down as human beings because yes, science is a very competitive, and you want to be the first to publish this new discovery. But I think collaboration is the way to go in the future, and actually from now on and in the future, because more and more the science become very difficult, and even if you're very niched in your expertise, it's really hard to track what's happening here and there. And I'm wondering, like, in terms of financing, if you could yourself, like, let's say you are the lab head and finance your own research in some way. Let's say you're an entrepreneur and also a scientist, and you have your many companies. And for example, this is what Elon Musk do with SpaceX exploration. And I'm wondering at which level you could do this, because yes, there's a bias, but at which level of notoriety this bias is somewhat removed. So um, I believe that in some way in the future, the only way actually to do um, the to have freedom in science is to have better financing than the taxpayers. Actually, it's not the problem of the taxpayers. Again, it's the problem of the government deciding how to reinvest this money. And let's say you 50% of the taxes go through, for the military, and you give 30% to health itself, and 10% to that, 10% to that, and you leave 5% to research and basic science. Well, sometimes, maybe government needs to reevaluate their priorities. And I think basic science should be, universal, and it shouldn't be limited by a country, which is sadly the truth. But yeah, so this is something I'm asking myself. So if there's other way to finance research and basic science, if you have ideas, feel free to reach out to me. I'm be happy to, listen to them. I am really willing to find ways, to help basic science. And yeah, this is one of the reason I created this podcast, is not only for scientists but also you as a big public, so you know how sometimes science is done, the different type of thought school of thoughts on how to do science, because there's no universal way one scientist could find results. But yeah, I hope you enjoyed this one. Again, to summarize it, there's only one good type of scientist, the hypothesis driven one. I'm sorry for the other one because I don't believe in it. And yeah, as a as people who are in the taxpayer proportion of the society, you should be aware that sometimes, even in the academic sphere, your money, I feel, goes to waste sometimes. It's not like the fact that you fail experiments. This is part of the job, but just doing an experiment without a purpose. This is for me the strong point here to remember. And again, I'm just scratching my head on other ways to help basic science thrive, because we need it more than ever. I think we need this basic science, and because more and more people are leaning toward transitional or more applied science, which is very cool. I really love applied science, for example. But if you just do applied science without any foundation, um, it's again, you do it without a purpose. So yeah, that was it. I hope you enjoyed, and see you in the next episode. I don't know if in the next one I will have a guest or not. We'll see. So take care.